Hello guys, welcome back to A to Z Dentistry, a channel which features easy explanation of various dental and medical related topics. And our today's topic is theories for mineralization of calculus. And in that we'll be studying about saturation theory and seeding theory. So without any further delay, let's get started. So we will be studying about the introduction, as in what is calculus. Then we'll move on to the saturation theory in detail, followed by seeding agent theory in detail. So let's begin. Coming to the introduction, so calculus basically consists of mineralized bacterial plaque that forms on the surfaces of natural teeth and on dental prostheses, right? So it is a mineralized bacterial plaque, right, which is formed on the surfaces of our natural dentition as well as on the surfaces of dental prostheses. Now this transformation of plaque into calculus results because of the mineralization of the plaque by various mechanisms. So plaque, as you know, it's relatively soft in consistency when compared to calculus, which is hard and mineralized in consistency. So what happens is that over a longer period of time this plaque gets converted into calculus because there is deposition of certain minerals onto it, and there are broadly two mechanisms which are responsible for this mineralization, which consists of our two theories. So let's deep dive into these theories. So our first theory is mineral precipitation theory. So as the name suggests, there are certain minerals which gets precipitated on the surface of the plaque, resulting in its hardening followed by formation of calculus. So mineral precipitation results from a local rise in the degree of saturation of calcium ions and phosphate ions. Now these increase in the degree of saturation of these ions is brought about by the following ways, right? So first is a rise in the pH of the saliva causes the precipitation of calcium phosphate salts by lowering the precipitation constant. So as we know that calcium phosphate salts are naturally present in our saliva. So a rise in the pH causes more amount of precipitation of this mineral by lowering the precipitation constant. Now the second reason is the colloidal proteins in the saliva bind calcium ions as well as phosphate ions and maintain a supersaturated solution with respect to the calcium phosphate salts. Now there is phosphatase, an enzyme which is liberated from the dental plaque, desquamated epithelial cells or bacteria, right? So what happens is that this enzymes precipitates the calcium phosphate by hydrolyzing the organic phosphates which are present in the saliva, thereby increasing the concentration of free phosphate ions. And ultimately these free phosphate ions again encourage the formation of calcium phosphate salts, and these get deposited onto the surface of dental plaque. This is followed by stagnation of the saliva. Now when the saliva gets stagnated, all the colloids which are present within it, they settle out, and the supersaturated state of saliva, right, with calcium and phosphate is no longer maintained, and thereby this leads to the precipitation of calcium phosphate salts. So apart from phosphatase, which is leading to the increase in concentration of free phosphatans, we have esterase enzyme, right? Now this enzyme is present in coca and filamentous organisms. Apart from it, these are also found in the WBCs, macrophages and desquamated epithelial cells of the dental plaque. Now this enzyme esterase can initiate the calcification by hydrolyzing the fatty esters into free fatty acids. So this is another enzymatic mechanism by which the calcification can occur. Apart from this, the fatty acids form soaps with calcium and magnesium that are later converted into less soluble calcium phosphate salts. So these fatty acids, they conjugate with this calcium and magnesium ions that are freely available in the saliva, and later they get converted into the less soluble calcium and phosphate salts, which again get precipitated onto the surface of dental plaque, right? So basically all this is occurring because there is a local rise in the pH which is causing the colloids to settle out, and there are certain enzymes which are helping in this for formation of calcification, that is phosphatase and esterase enzyme. Mainly these two enzymes are responsible, which are again liberated from the dental plaque itself, desquamated epithelial cells or the various cocci and the bacteria which are present within the dental plaque, right? Moving on to our next theory, that is seeding agent theory, right? So what are these seeding agents? These are basically the agents which induce small foci of calcification that over time gets enlarged and they join together or they coalesce to form a calcified mass, right? So this concept is also known as epitactic concept or heterogeneous nucleation, right? So this is very important, this line, right? The seeding agent theory is also known as the epitactic concept or the heterogeneous nucleation, right? So these seeding agents in the calculus formation are not known, but then again some say that the intercellular matrix of the plaque itself plays an active role. So in both the theories, the plaque itself is acting as a foci for the calcification to occur. So in seeding agent theory as well, it is believed that the intercellular matrix of plaque plays a very crucial role in formation of this calcified layer. So the carbohydrate protein complexes initiate calcification by removing the calcium from the saliva, that is by process of chelation, and they bind it to form nuclei that induces subsequent deposition of minerals, right? So what happens is that within the saliva there are certain minerals present, right? So what the seeding agent do is that they initiate the calcification by removing these ions from the saliva, and they tend to bind it with a nuclei that again promotes binding of more number of salts to this nuclei, and then gradually it becomes a whole layer, right? So it enlarges and coalesces to form a big calcified mass. This is how the plaque is getting converted into calculus, by drawing out certain minerals from the dental plaque as well as saliva, and then these salts ultimately get deposited onto the surface of the dental plaque, resulting in its hardening and calcification to form calculus. Alright, so a quick revision what we have learned so far. So we started with the calculus. Basically, it consists of mineralized bacterial plaque that forms on the surfaces of natural teeth as well as dental prostheses, right? Now the transformation of this dental plaque into the calculus is because of the deposition of certain salts onto the surface of dental plaque, and there are two theories which explain the conversion of this dental plaque into mineralized calculus, right? So our first theory was mineral precipitation theory, also known as the saturation theory, right? So it states that the mineral precipitation results because of the local rise in the degree of saturation of calcium and phosphate ions, right? And this occurs because there is again lowering of the precipitation constant. Now this lowering of the precipitation constant leads to the colloidal proteins, basically, which are present in the saliva to bind to calcium and phosphate ions, right? And there are two enzymes which are largely responsible for this mechanism, right? One is phosphatase, right? We have studied that this phosphatase enzyme is liberated from the dental plaque, desquamated epithelial cells, and the bacteria, and this precipitates calcium phosphate by hydrolyzing the organic phosphates which are present in the saliva, and it also thereby increases the concentration of free phosphate ions which are present in the saliva, right? Apart from it, we have learned about esterase, right? This is present in the cocci and the filamentous organisms. Apart from it, it is also present in macrophages and desquamated epithelial cells of the plaque. Now it can induce the calcification by hydrolyzing the free esters into the fatty acids, right? Now these fatty acids tends to form soaps with calcium and magnesium that are present, and again this gets converted into the less soluble calcium phosphate salts which get deposited onto the surface of dental plaque. Then we have studied about next theory, that is the seeding agent theory, which states that this seeding agent induce small foci of calcification that ultimately enlarge and coalesce to form a big calcified mass, right? So the carbohydrate protein complexes initiate this type of calcification by removing the calcium from the saliva and binding it to form nuclei that induces the deposition of other minerals, right? So this was about seeding theory. Now it is also said that these seeding agents are particularly present in the intercellular matrix of plaque, and this plays a very active role in this seeding agent theory. So this was all about the mechanism for calcification of dental plaque to form calculus. I hope you understood this topic very well. So this was all about theories for mineralization of calculus. I hope you all understood this topic very well. Thank you for watching this video. This is Dr. Snell signing off. Bye bye. Take care.